if-else statement, one of the most fundamental and widely used control structures in C programming, especially in embedded systems, is the if statement. When your C program reads an if, it evaluates the condition written inside the parentheses. If the condition is true, the program executes the block of code that follows. If it's false, the program either skips that block or executes an alternate path, depending on how you written your if structure. That's why the if statement plays a central role in decision making and flow control, making it a must-have tool when programming microcontroller. Let's look at a practical example. Imagine a temperature sensor connected to a microcontroller, continuously sending temperature data. With the help of the if statement, we can write a C program that checks whether the temperature is below 20 degrees Celsius. If it is, the program can activate a heating device. And if the temperature exceeds 30 degrees Celsius, it can turn on a cooling system. This simple logic is driven entirely by if statements, and that's what make them so essential in real-world applications. Now, the if structure in C can generally be divided into three main types: basic if and if-else statements, the if-else ladder, and number three, nested if-else statements. Number one, basic if statement. This is the simplest form. You place a condition inside parentheses followed by a pair of curly braces that enclose the block of code to be executed if the condition is true. It doesn't matter where the opening brace is on the same line or the next, though placing it on the same line improves readability. If the condition is not met, the program skips this block and continues with the next part of the code. Number two, if-else statement. This version adds an alternative. If the condition is true, the program runs the block inside if. Otherwise, it runs the block inside else. This helps manage two possible outcomes cleanly and clearly. Number three, if-else ladder. This structure is used when you need to check multiple conditions in sequence. It starts with an if and its block, followed by one or more else if conditions, and end with an else block for all remaining cases. Each condition is evaluated one by one until a true condition is found. If none match, the else block is executed. Number four, nested if-else statements. This is when you place one if or if-else inside another. You can use it to create more complex decision trees, especially when several conditions must be met together or in a specific sequence. Here's a quick tip. If your if or else block contains only one statement, you can write it in a single line without curly braces. You can also use the Ternary operator to write conditional statements in a single line. With the ternary operator, you start by writing the condition you want to check, followed by a question mark. Next, you write the expression to execute if the condition is true. Then add a colon symbol, and finally the expression to execute if the condition is false. Let's see two examples. As you can see, in the ternary operator lets you write the same logic in a much more compact and cleaner way. But disadvantages of the ternary operator. Number one, readability issues with complex logic. When the condition is complex or the actions to be executed are lengthy, the ternary operator can make the code harder to understand and less readable. Number two, not ideal for multiple actions. The ternary operator is best for simple assignments or expressions. Number two, not ideal for multiple actions. The ternary operator is best for simple assignments or expressions. If you need to execute multiple statements, it's better to use a full if-else block. Number three, potential for misuse. Using ternary operator excessively or in complex conditions can lead to confusion, making the code harder to maintain. We've already written several programs before, and you can find the playlist link at the top of the page. In the next part of this video, we'll jump into the Eclipse IDE. Inside the main function, we start writing our program. First, we declare a variable named temp of type float. This variable can store ambient temperature. Before checking any condition, we prompt the user to enter temperature using please enter temperature. Then we use the scanf function to read input number from the keyboard. We have three temperature ranges. Number one, 30 degrees Celsius or above. If the temperature is 30 degrees Celsius or higher, the cooler should be turned on. In this case, both the heater and fan must be turned off. This will be indicated by printing the corresponding message to the console. Number two, 20 degrees Celsius or below. If the temperature is 20 degrees Celsius or lower, the heater should be turned on. In this case, both the cooler and fan must be turned off. If the condition is true, the output will display turn on heater. between 20 degrees Celsius and 30 degrees Celsius. If the temperature is between 20 degrees Celsius and 30 degrees Celsius, this condition is checked using the logical AND operator. If true, the fan should be turned on while both cooler and heater must be turned off. Finally, we include an else block if none of above conditions are met. The system should report an error message, invalid temperature. We now debug the program to observe the output. First, we input 19 degrees Celsius. First, we input 19 degrees Celsius. We see that the program executes the second condition where the temperature is less than or equal to 20. Next, we restart the program and input 35 degrees Celsius. This time, the program runs the first condition where temperature is greater than or equal to 30. Finally, we input 25 degrees Celsius. We see the program runs the third condition where the temperature falls between 20 and 30 degrees. This simple code example will be uploaded to GitHub so you can download and practice it yourself. Remember, one oil well beats 10 water wells. Dig deep, treasures await. Our next video will be about switch case statements. You can find the playlist of our previous videos right here. Good luck.